Yes, it's working. Okay. So what is important with these problems is we are testing our understanding and practicing those tables. I should say it's basically one table that I am going to use for the rest of the semester in chapters 3 and 4. And we are going to add 2 more rows to this. So please try to get used to this. It's extremely important to understand what follows next. Okay, limit of f of x as x approaches negative infinity is negative infinity. Don't cross it out like that. I'm just trying to make a point. That is done. Now we're talking about 2. Okay, so 0 is somewhere here, 2 is here. It says 2 from the left. 2 from the left in the parenthesis is infinity. 2 from the left in a parenthesis is infinity. Done. 2 from the right is negative infinity. Done. This makes no sense. Because they're telling us the limit from the left is infinity, the limit from the right is negative infinity. The limit from either side of 2 cannot be infinity. I mean, is it infinity or is it negative? It cannot be both. So I'm going to change this into a different number. Just give me any number but 2.
4.
It doesn't work. Something is wrong. They have a typo. So I'm going to make myself a note and let them know. So this was in 2.5, problem 8. Okay, no, it's 2.6, sorry. 2.6, problem 8. Okay. So then this makes sense. And this is done. And then limit of f of x as x approaches infinity is infinity. Done. So obviously this must be x equals 2 is a vertical asymptote. Of course, x equals 4 must be a vertical asymptote. And these are not horizontal asymptotes, because these are not numbers. If I have here 4, then I'll have y equals 4 horizontal asymptote at negative infinity. Okay, so now I'm ready to graph, and I'm going to graph it here because I have the table. I will graph, so 1, 2, 3, 4. So x equals 2 and x equals 4. So at 2 to the left is infinity, and here is negative infinity. So my choice is this. Negative infinity. And somehow getting closer and closer, not touching the left-hand side of the vertical asymptote x equals 2, it goes to infinity. Now between these two asymptotes, it's coming from negative infinity and going to positive infinity. Fine. On the right-hand side of the vertical asymptote, it's coming from negative infinity. On the left-hand side of this vertical asymptote, it's going to positive infinity, as well as here. And then I'm going to say it does this. Why? Because it has to go to infinity. It cannot go to negative infinity. It cannot be a horizontal asymptote. So here's my example. Of course, there are a million different other examples that will fit the information we have. This is not the only correct answer. You can come up with any other function that you feel like. Okay, one last type of problem that I would like to look at before we move on is something like, where are you guys? Right here. I lost you. Okay, I got you back. Okay, is a problem like this in which we're asked to determine the horizontal and vertical asymptotes. No, I'm not asking you to use the calculator and graph. And we can check graphing if that's what you want. But I want to show you the entire presentation. So this has to be presented with the limits. Okay, I'm ready. You choose the next problem. Okay, I'll choose 49 if you don't want to choose. So I have y equals 2x squared plus 1 over 3x squared plus 2x minus 1. 2x squared. Oh, I copied something else, right? I'm always doing that. 2x squared plus x minus 1, and the denominator is x squared plus x minus 2. X squared plus x minus 2. Okay. Done. So this problem, and this is a potential problem on a test, very important type of problem. We're asked to find if this function has horizontal and vertical asymptotes, and I will specify and the limits and all necessary limits. Okay, so first I will start with horizontal. It doesn't matter, you can start with vertical. It's really not important. So for horizontal, I know I have to find the limit since it's a rational function. Rational function. Rational function, good. There is no need to find the limit as x approaches positive and negative infinity. One is good enough. One or the other, it doesn't matter. You will have the same asymptote, horizontal asymptote at both sides. So horizontal asymptote. So just one or the other, not both. What do we need to do? Let me copy it. What is the first step?
Plug in.
Yes. Where does this go? Where does this go? Thinking in terms of positive infinity. Not both. There is no need. Doesn't matter the sign. So, where does the top go?
Infinity.
Good. And the bottom?
Infinity.
Right, because these terms are too small to mention when we talk about infinities. These dictate. Good. So then what is the next step?
Pull out the biggest number, the biggest exponent.
Good. So what do I factor out then?
X squared.
Very good. What is left? Anyone?
Two plus 1 over x minus 1 over x squared.
Thank you very much. And the bottom? Thank you.
1
Yes?
plus 1 over x minus 2x cubed.
Right? 2
Squared,
over x
right.
squared. Because x squared times 2 over x squared will give us negative 2. Of course, this is what we just did. What is this limit?
Two.
Very good. Y equals 2, horizontal asymptote. Done. I'm finished with the horizontal asymptote. Now I want to talk about vertical. Good. So we have, first of all, the function, which is 2x squared plus x minus 1. We will have to factor the denominator. Can anyone give us the denominator in the factored form? Anyone? I haven't heard from Rihanna and Sean. Anyone?
X minus 2, x minus 1.
X minus 2. Careful. First of all, the middle term is positive. So negative 2 times negative 1, first of all, it's not negative 2. So I'm thinking that you mean x plus 2 and x minus 1.
Oh, yeah, sorry.
That's okay. Perfect. So what are the restrictions for this function?
Negative 2 and 1.
Negative 2 and positive 1. Well done. Now, we also have to try to factor the numerator to make sure Because if you remember, if, it's a big if I have x minus 1 over x plus 2, x minus 1, and I simplify after I state the restriction, x equals 1 will not be a vertical asymptote. It will be a hole in the graph. So I also have to look at the numerator and see if the numerator is factorable or if it has any of these factors. Because if it has either one of them, I will be able to simplify. If it does not have any of these factors, then both will come out to be vertical asymptotes. This will be a vertical asymptote as well as this. So VA and VA only if the factors do not go away with the factor from the top. Okay. So I want to talk about for a moment, and then I'll come back, something called the remainder theorem. The remainder theorem. You may remember it from pre-calculus or you may not. It's okay. Now, let's say I have a polynomial p of x. It's this one, 2x squared plus x minus 1. And let's say I evaluate at -2. And I evaluate at 1. If the answer is 0, then x plus 2 is a factor of p of x. If the answer is 0, then x minus 1 is a factor of p of x. That's how I check quickly. So let's plug it in. Well, this is 4 times 2 is 8. It's not going to be 0. No. Let's plug in 1. 2 plus 1 is 3. Minus 1 is not 0. So I know that the numerator does not have a factor of x plus 2 and a factor of x minus 1, which guarantees these two to be vertical asymptotes. But this is not enough. I know that these two will be vertical asymptotes. I have to find the limit from the left of -2, from the right of -2, from the left of 1, and from the right of 1. Why? Because when I state that x equals 2 is a vertical asymptote, I have to show the limits, whatever they are. Positive, positive, negative, negative, positive, negative, negative, positive. It doesn't matter. When I state that x equals 2 is a vertical asymptote, I have to calculate the limits. When I state that x equals 4 is a vertical asymptote, I have to calculate the limits left and right. Just stating that, oh, these are vertical asymptotes is not enough. Okay, so that's my page 7. So now I have to find the limit as x approaches -2 from the left. 2x squared plus x minus 1 over x plus 2, x minus 1. And then the limit as x approaches -2 from the right, from 2x squared plus x minus 1 over x plus 2, x minus 1. And then limit as x approaches 1 from the left, from 2x squared plus x minus 1 over x plus 2, x minus 1. And finally, limit as x approaches 1 from the right, 2x squared plus x minus 1 over x plus 2, x minus 1. And you could say, oh, I know the answer. So do I. Of course I know the answer. But this is what I don't know. I don't know the sign. Of course I know all the answers, but I don't know the sign. So when I plug in -2, again, 4 times 2 is 8. 8 minus 2 is 6. 6 minus 1 is 5. I don't have any problem here. It's a positive number. And even with 1, 2 plus 1 is 3 minus 1, so this is still a positive number. But what is important now is the sign in the denominator. That's what I don't have. So -2 from the left, it's like plugging in here -2.1. Please plug it in and just tell me the sign. That's all I need. Don't give me the number. I only need the sign. What is the sign in the denominator?
Positive?
Yes, because this is negative and this is negative. So then I know the sign here.
Positive.
Done. So please plug in -2 from the right, which is -1.9. Plug it in and give me the sign, just the sign.
Negative.
Then we know the sign for the limit, and you see the limit. Thank you very much. The limit operator went away. No question. X equals -2 is a VA. Good. 1 from the left, like 0.9. Please plug it in. Just give me the sign.
Negative.
Negative?
And 1.1, something to the right of 1, very close. Just positive. Obviously, x equals 1 is a VA.